Welcome to Maths with Bob. Today we're looking at a fairly big topic called coordinate geometry, and there are quite a few ideas in this particular topic. And the first one is that how in the world do I differentiate between a point A and a point B in the number plane? Now the number plane consists of a two-dimensional plane. It has an x-axis and a y-axis, and it's a bit like how would I define a position on a map? I need some coordinates, a coordinate system, if you like, to define my position. And in the xy number plane, or just the Cartesian number plane sometimes as it's called, we just use a coordinate system, x and y. And you can see here I've put A as xy and B as xy. Now, obviously, I need to somehow or other differentiate the x values. Now, I think of it a bit like, runners in a running race. How would you differentiate the runners? Well, you put a number on them, okay? So what we do is we put numbers on the x's and numbers on the y's, and the numbers have got to match up. So x1, y1, x2, y2. So it's a bit like, let's have a look. Okay, so on A, we'll put a number 1 on its leg, and a number, now, should I put a 1 over here? No, well obviously I wouldn't put a 1 there as well. Obviously I would sort of change the number obviously to a 2, so I'd call that my second x value. Okay, now would I actually okay, so I've got my x numbers are now differentiated, an x1 and a y1, my first x point and my second x point. Now the first thing is, okay, I'm going to put 2's. Would I put a 2 next to the y here? Obviously not. Okay, this is the coordinates need to match up in that would be the y1, so I need to write that as y1, so I need to have an x1 and a y1. Just think of them like a one-legged race. Those two coordinates have to stay together, x1 and y1, and also with x2 and y2. Okay, now so once we've worked out that, okay, we use a little subscript to differentiate the actual points on the number plane itself, we then start looking at, back onto the x and y axis. Okay, so we'd have down here that along the x-axis that would be x1, this would be y1. Okay, so let's actually look at B now. Okay. These points now would be, this would be x2 and y2. Okay, so we now have x2, y2, x1, y1. Let's actually have a quick look. The difference in the heights would be, okay, hopefully we can see that this is going to be just y2 minus y1. Okay, and the difference in the x's, okay, down here would be just x2 minus x1. Okay, and the first formula we're going to look at is trying to find out how far apart the A and the B are. Now, we may be able to see that we could draw up a little triangle. We could actually draw up a little triangle here, and it'll be right angled in that corner, and we could actually use Pythagoras. And that's basically the formula we're going to use. We're going to actually use Pythagoras to try and find the distances between A and B. Then we have to try and look at the gradient. Now the gradient, let's have a look. If I actually drew that triangle in again, this is the rise and this is the run, okay? So the rise on the run is actually the tan of that angle there, theta, and so the slope is actually the rise on the run, okay? And we're going to try and work out a formula for the actual gradient or the slope of the interval AB, and hence a line going through AB would have that slope. Now the other formula is the midpoint, so we have to sort of somehow or other work out somewhere in the middle here and the middle there, and this is going to be the midpoint here. Okay, so the midpoint of A and B would be obviously the average of the x's and the average of the y's, and we're actually going to develop these formulas shortly. Okay, so let's actually have a quick look at the formulas. Okay, well let's have a look at the distance formula. You can see here I've drawn a little red triangle on the diagram, and there's a D being the hypotenuse opposite the right angle, and that's what we're going to actually need to find. That's the distance between the 2 points A and B. Now we've got A and B as the sides of this particular right angle triangle. Now I'm going to write Pythagoras' result now. And we know that d squared equals a squared plus b squared, okay? So we know that d squared equals a squared plus b squared, but I'm actually going to write it as b squared plus a squared. Okay, now the reason I do this is because I normally put the x's before the y's. Okay, so when I actually do this, I do a substitution now for these values. We don't know what d is at the moment, so d is still d squared, but we do know what b is. B is really x2 minus x1, and remember we have to square this. What's a? Well, a is the difference in the y's, which is just y2 minus y1, and that's all squared. Okay, so when we put the numbers in, we obviously get a value for d squared here. But what we want is d. So we know that d, okay, would be equal. Now it's the square root. Now obviously distance is positive, so we take the positive square root, and I always write this as x2 minus x1 all squared plus y2 minus y1 all squared. Okay, we do it that way, or we could actually write it as y2 minus y1 all squared plus x2 minus x1 all squared. Okay, it wouldn't matter. But there's another interesting point. What happens if I swap the points around? Does the formula, or do all these formulas work? The answer is yes. It doesn't matter what point I select as x1, y1, and what point I select as x2, y2. What I normally do, as I said, is the first point I come across is I always label it as x1, y1, and x2, y2 as the next point. Okay, all right. Thank you. We'll go on to the next one. Look at the gradient formula. Now, the gradient formula is the rise on the run, and we normally write down a symbol for the gradient is m. Okay, so m. M equals the rise over the run. You can have a look here. The rise on the run is, well, the rise is, let's see here, y2 minus y1 on x2 minus x1. Okay, this is m, the gradient or the slope of the line, and you can see it's positive. It's as you walk from the left to the right, it's going uphill. We say that's a positive gradient. If you were working left to right and you went downhill, that would be a negative slope. So we say that's a positive slope. Just while we're on this, this is related to trigonometry too. You might remember that's the opposite in the hypotenuse, and this is, so the m is equal to tan of the angle theta. So if someone said to you, okay, say the slope was 2. Okay, let's say the slope was 2. What was the angle it made with the positive direction of the x-axis? So let's say the slope is 2 is equal to tan theta. What is theta? You might remember from trigonometry, theta equals tan to the minus 1 of 2. If you type that into the calculator, I think it's about 63 degrees. You have to go, remember you have to go shift tan 2, and it's about 63 degrees 26 minutes. So it's about, so theta is approximately 63 degrees and 26 minutes, right? Okay, so you can see that the actual slope or gradient is actually related to the angle, obviously through trigonometry, rise on run. Normally when we actually find an expression for the gradient, okay, it normally is a number. Obviously the bigger the number, the steeper the gradient, obviously, hence the steeper the line if it went through AB, and those ideas. And I'll just fix up, there's a bit of a 2 missing here. Okay, all right. We'll now have a look at the midpoint formula. Okay, let's have a look at the midpoint formula. Now, the midpoint, where would the midpoint be? Okay, let's have a quick look. Okay, so the midpoint is somewhere here. This is the midpoint. Okay, it's actually halfway between A and B. When you think about it like that, it's like the average of the x's and the average of the y, so it's halfway between. Let's call that capital M. Okay, so to find the midpoint, capital M, all you do is, some people say it's the average of the x's and the average of the y's, but I just like to say it's x1 plus x2 on 2, and then comma, y1 plus y2 all over 2. So it's just the average of the x's and the average of the y's. Okay, so it's halfway between. So this is a fairly simple formula. You can see here, it wouldn't really matter where the x and the y's are in the number plane. As for all these formulas, they can be in the first, second, third, or fourth quadrants. And we'll do some examples using these formulas in the next video. Thank you for watching. Bye.